Hi, I'm Eric, Director of Training here at Just Add Power. And in this video, we're setting up an AMP system with multiple switches. There's two reasons that you would use multiple switches in an AV over IP system. Reason number one is you have more devices than a single switch can handle. The largest switch for an AMP system is going to have 48 ports, and you've got one port for your network connection, so that gives you up to 47 devices. So if you have more than 47 devices, you're going to need two switches minimum. And so you would need multiple switches in your AV over IP system. The second situation that you would need multiple switches is if you have two locations that all your wires are running back to. So you've got one location where your transmitters and receivers are wired back to, and then you've got another location that's far enough away where you can't run network wiring from one section to that other section. So you're going to run fiber between two locations, and then you're going to run all your Cat5 wires to the second location. We are using that second location in this video, but the rules for setup are exactly the same, whether you've got more devices than can be handled on one switch and all the switches are in one rack, or if you've got to do two locations, they might be smaller switches, but the point is we can't home run all of the Cat5 cables to the same location. So either one of those situations, this is the video for you. So let's explain the hardware we've got in front of us so that you know what we're working with. So this table is going to represent the main rack in your system. And the thing that makes it the main rack is that it's the rack that has the router, or the thing that connects from the network to your Just Add Power AV over IP system. So this is switch 1 in our system. That's going to be our uplink to the rest of the network for control of the system once it's finished being set up. We've got our Netgear switch here as our switch 1 in the system. We've got transmitters and receivers that are going to be connected to this switch. Within distance of the switch, we'll be connecting those as we run through the software. One of the important things is that all of the switches in a multi-switch system must be of the same manufacturer. So because I have a Netgear switch here, in the other rack, you're going to see another Netgear switch. They don't have to be the same size. You can have a 10-port mixed with a 24-port, mixed with a 40-port switch, but they must all be Netgear in order for AMP to set up the system. So now let's go look at the other side of our system. So this table is going to represent the other switch in our system. Now, as we said at the beginning, this switch can be in the main rack with the first switch, or it can be in a completely separate location connected over fiber. In this video, this is a separate system connected with fiber, but they could be right next to each other. Either way, this is our second switch in the system. It's a Netgear switch purely because the other switch was a Netgear. As long as you have a supported model on our website, it doesn't matter what brand you go with, but remember they all have to be the same manufacturer. We've got our switch, we've got our transmitters that are going to be on this switch, and all of our receivers that are also going to be on this switch. So now let's get started setting up the system. All right, we're just going to start by opening AMP on our computer. Whoa. Where is it? There it is. I'm going to give it administrator access. We are setting up a VLAN system, so I'm going to select VLAN, and we are configuring a new system. We need to have a wired network adapter in order to set up a project. So first we're going to name our project AMP VLAN multi-switch system. And then I don't have any network adapters connected at the moment, so I'm going to start by connecting my router to my computer. Back in AMP, I'm going to hit the little arrows. It's going to show up my Ethernet adapter. I'm going to hit go. We have to enter the network information for the switch, or in this case, switches, that will be in our system. I'm going to start by selecting manufacturer. We have Netgear switches. The program will show us the username and password it's going to assign to the system. You can't actually change that username and password through this. It's something you can change later after the fact. Now that I've got Netgear, I'm going to select the model of switch that I have for the system. I have the 4212PX. And then all the way on the right side, since I have two switches, I'm going to click the plus sign to add a second switch. I'm going to select my second switch, And I also have a 4212px for the second switch. Now we have to give this switch an IP address. 192.168.0.11 has been set aside in this system for the just add power switch. The subnet mask for the network is 255.255.255.0. And the gateway, which is the IP of the router in our system, is 192.168.0.1. For the second switch, you'll notice that all of the IP address, net mask, and gateway information is filled in automatically. The net mask is exactly the same, the gateway is exactly the same, and the IP address is one IP higher than the one that was set for switch 1. I can even go in here and change the IP address for switch 1, and you'll notice the IP for switch 2 updates automatically to be the next sequential IP address. So when you have multiple switches in a system, make sure that you have set aside not just one IP, but one IP sequentially for each switch in the system. If I have a lot more switches, I'm just going from 11 to 12 to 13, 14, 15, 16. So I have to make sure that all those IPs are open. Part of the system requires the IPs to be sequential. So if we know where switch 1 is, we automatically know where switch 2 is. We don't have to be guessing about where your other IPs are. Now that we've got everything active, we're going to hit generate. So the thing that's being generated is a discovery configuration file for each switch in the system. I'm going to hit generate, and it's going to give me a save prompt to save the switch config file for switch 1. And I'm going to hit save. I'm going to put this on my desktop so it's easy to find. We're going to use it real fast. And then it's going to give me another save prompt for switch 2. So I'm going to get one file for each switch in my system. Now that all the switches have config files, the next step is to upload the config file. So we're going to leave AMP exactly where it is, and we're going to go into the switch to upload those configs. So I'm going to start by connecting the switches to my network, because they're not connected yet. In order to do that, we're going to go right into my router, and we're going to go into the last port on the switch. The last port is the one that we use for the network uplink. It's not mandatory, it's connected to the last port now, but I'm saving myself a step because it's going to have to be there eventually. And because we have two switches, I also need to connect the second switch. So I'm going to go all the way over here to switch number 2. You'll see that switch in just a second. Now that both of the switches are connected, I've got to get into their web interface, and I've got to upload those discovery config files. I don't know the IP address of those switches right now, so I have to figure out what IP they're at. Netgear switches pick up a DHCP address by default. So I'm going to log into my router. I'm going to go to status. I'm going to go to connected clients. And right there, you see my first switch in the system at 192.168.0.115. Open up a web browser for that. Log in. It makes me create a new password. So I'm just going to create a new password just so I can get into it. It doesn't really matter what the password is at this point because the config file is going to overwrite that anyway. So we'll go admin, just add power. All right, we're going to go to maintenance, and then we're going to restore the config file that we just got. So because this is switch 1, I'm choosing DC for discovery config 1. Open and upload. I hit restore now. That file is officially uploaded into switch number 1. Close that window, and we'll move on to switch number 2. We're going back to our router interface to find our second switch. There it is. So the way we know it's different from the first switch is because the MAC address is different. So you'll notice one of these is 9B2E07. In fact, you can see the same thing at .11 and .115, because 115 was the old IP address, And 11 is the new IP address after we uploaded the discovery config file to the first switch. So we've got a different MAC address, so we know this second IP is our second switch. That MAC address is printed on the front or the bottom of the switch, so that's how we identify multiple switches. We're logging into that one. We're putting in our username and password, doing the same thing we did for switch 1, going to maintenance, browse file, and here's the part that's different. We're doing discovery config, DC, but because it's switch 2, we're doing the DC2 file. Open, upload, restore now. Both of the switches now have the discovery config file. If you have more switches than that, lather, rinse, repeat for every switch in your system. We're done with our router interface for now. We're going to go back to AMP, and we've got one more connection we have to make before we're good to move forward. The last thing we need to do before moving forward is we have to get the trunk connection between the switches hooked up. So right now, switch number 2 is connected to our router, but that's not where it's connected when the system runs. So we're going to disconnect it from our router. We used that purely for our network connection to upload the discovery config, so done with that. Now we need to connect the 10 gigabit port on our switch 1 to the 10 gigabit port on the switch 2. Because I've got a lot of video traffic that's going to go between these switches, I need a 10 gigabit port. In order to do that, I need a special connector. This is an SFP connector. It's SFP plus. It does a 10 gigabit connection. But this is clearly too short to go between those two switches. So I'm not using something like this if they're in separate racks. I can use it if they're right next to each other and they're just going top to bottom. Instead, what I need fiber modules for a fiber wire connecting the switches together. So here I've got my fiber wire, push my fiber into my module, and then my module into the stack port on the switch, the SFP plus port on the switch. That wire is going over to switch number 2. I've got my fiber connector into my fiber cable into my fiber module. It's okay, they're not fragile. Connect that in, connect around to the stacking port of switch 2. Sorry, trunk port of switch 2. They don't stack. Now they're connected. We're heading back into AMP. We've done all the instructions in the pop-up, so we're going to click Discovery Config Uploaded. This page is the meat and potatoes of your entire system. You're telling each switch how many receivers and how many transmitters are going to be connected to each one. This is also where you build not only for the pieces you have right now, but the pieces that you might expand into. So on switch number 1, we've got a maximum number of just add power ports of 9 ports. Because there's a 10-port switch, one of those ports is used for our network uplink. So we've got 9 of those ports available. We're going to do 4 receivers and 4 transmitters on that switch. We don't actually have 4 receivers and 4 transmitters, but we're building for expansion. We're going to do the same thing on switch number 2, 4 receivers and 4 transmitters. Mostly because this switch only has 8 PoE ports, so I'm just using 4 and 4. But when you've got a bigger system, you can put any number of receivers and any number of transmitters on any switch in your system. Your sources don't have to be locked on one switch. Your receivers don't have to be locked on one switch. You get the ability to mix and match transmitters and receivers however you'd like. Once I'm done assigning my receivers and transmitters, I'm going to hit Go. And the program is going to give me a diagram of how my receivers and transmitters are connected to each switch in the system. If you look at the diagram, the 10 on switch number 1, it's an orange port. That's my LAN uplink. In order for us to move forward, that port has to be connected to my network. You might have been able to get away with it on other ports before this point, but from this point forward, port 10 on switch 1 must be connected to the rest of my network. Then on switch 1, the first 4 ports are receivers. The next 4 ports are transmitters. Same thing for switch 2. Receivers in the front, transmitters in the back. So let's get everything hooked up. So we're in front of switch 1. We've got to connect our receivers and transmitters to the switch. So I'm just going to start at the beginning. We're going to go port 1. Diagram says that is a receiver going over to our far left receiver. Port 2, also a receiver. Just going to go in order. It doesn't matter how you connect receivers to the switch as long as receivers go in receiver ports and transmitters go in transmitter ports. So here we go. Receiver number 3 over to receiver number 3. Receiver port 4 over to receiver number 4. Straighten up those wires a little bit. All right. Then the next ports are transmitters. So we go port 5 to our first transmitter, and port 6 to our second transmitter. And we do have ports 7 and 8 for transmitters, but I don't have those right now. I built it for a little bit of extra space in case I needed to add 2 transmitters. So switch 1's hooked up. We're going to move over to switch 2. Switch 2, we're going to make our same connections. Port 1, receiver. Port 2, also a receiver. Port 3, also a receiver. Port 4, guess what? It's a receiver. Port 5 is our first transmitter on switch 2. And port 6 is our second transmitter on switch 2. And just like we had on the first switch, we've got 2 ports open for extra transmitters if we want to add them later. Time to head back to AMP and move forward. Now that all our devices are connected to the switch, we're going to hit Discover. AMP is going to go out and look for all of those devices that we have connected to the switch. We've got 4 receivers on switch 1, 4 receivers on switch 2, 2 transmitters on switch 1, 2 transmitters on switch 2. It's going to log in to each one of those devices, ask them what model, what firmware, what port they're connected to, and give us a table as soon as it's gotten all that information. So we're just waiting for all of that to populate. Behold the dancing dots. When there are devices in your system that are not on the latest firmware, you're going to get a pop-up that says, we need to update firmware on devices. If you ever get this pop-up, you need to update firmware. And that's the very first thing that we're going to do. So we're going to hit Update. It's going to give us one confirmation. Yes, I want to go to the latest firmware. I'm going to hit Update. The update takes 8 minutes, so we'll see you in 8 minutes. Now that firmware is up to date on every device in the system, we've got 2 things going on. We've got a diagram at the top of the screen that shows where devices are connected. Any ports that are green show a device connected to the correct port, meaning a receiver in a receiver port or a transmitter in a transmitter port. Any ports that are colored as though they're a transmitter or a receiver just means those ports are programmed for a transmitter or receiver, but there's nothing connected to them right now. So you'll see ports 7 and 8 on switch 1 and switch 2 don't have transmitters connected to them. If they're supposed to have transmitters connected to them at this point in the software, you need to go check those devices. They should be showing you a solid power light and a dark data light if they were discovered by the program. If they weren't discovered, you should be seeing a solid power light and a blinking data light, that means the device is fully functional, the network cable is functional, it's getting PoE, but the program hasn't picked it up. If it's showing any other light behavior, you probably need to check your network cable. The connection from the device to the switch is not functional. If you have any ports that are red, a red means there's an error, which means you've got a transmitter connected to a receiver port or a receiver connected to a transmitter port. Once we move past this window, only the devices in green ports are going to be configured. So if the diagram matches the ports that you have connected, we go down to the table. The table shows us the unit and the port, unit being the switch, and the port number that each device is attached to, tells us if it's a receiver or a transmitter, gives us the IP address currently, the MAC address, and the firmware on those devices. Once all devices have been found, we're going to hit the button that says, all devices found. The next table is going to give you a list of the new IP that is going to go on every device. Now, you can't pick these IPs. Part of the AMP program is that it creates a standard. And the standard has us assigning IP addresses all in the 172.27 network range. And then the third and the fourth number is going to be different for each device. So you'll see our receivers are 1.1, 1.2, 1.3. The receivers on switch 2 are 2.1, 2.2, 2.3. Same thing with the transmitters. They're getting their own IP addresses, so we can get to everything on the switch later when the system is fully functioning. This is just a confirmation window. We're going to hit Configure Devices. Pop-up pretty much just is a confirmation box. So we're going to hit Configure one more time, and the program's going to configure devices. Once devices have been configured, they're going to reboot at their new IP address. We're just waiting now for those devices to come back online at their new IP and for the program to confirm that it has configured all the devices in the system. This is, again, more of a confirmation screen. You can see that our IP address, that central column, has the new IP for all the transmitters and all receivers. If anything was missing, you'd hit the rescan button, but we've got everything in our system here. The last thing to do is to configure the switch. The program is going to do this itself. You don't have to do anything to do the final config of the switch, but once I hit this button, there is no going back. So if we had missed a device up to this point, we have to go back and do that device now, or we're going to finish configuring the system, and then there are ways to add the devices to the system later through separate processes. We are ready to go, so we're going to click Do It. Final switch configuration is applied to all switches in the system, and we're just going to sit here and wait for the timer to count down for the switches to reboot. Now that the switch is configured, the system is fully set up. We do need to save a report file. We want to make sure that we've got documentation that goes along with this system. So if we need to do maintenance on it later, we want to add those extra transmitters we were missing. It has all the information about the switches, the transmitters, the receivers, and then any extra ports that devices can be added to later. We're just going to save that in wherever you save your project files for this system, because it's very important if you ever have to do any maintenance on it. We're not going to test switching yet because there's one more thing we have to set up before we can test switching. So we are finished with our system configuration. The program is going to clean up all the stuff that it did to your computer's network adapter so that you're right back at the state you were before you ran AMP. Now, we do want to do some switching to make sure that the system is functional. But before we can do that, we have to add a static route to our router. And that's where that report file comes in handy, because the report file has the information that we need to add to the router in the system in order to control your AV over IP system. So our information's right here. We're going to log into our router. We're going to go down to the network option to routing. And our description is just add power. And our information about the destination IP and all that is going to be pulled directly from our report file. So destination is 172.27.0.0. Net mask is 255.255.0.0. And the gateway, that number should look familiar. That is the IP address of switch 1 in the system. We're going to hit add. We're going to apply that static route. And right there at the top of our system is our active route to control the system. We're done in our router. We're going back to AMP. We're going to hit VLAN, and we're going to connect to the system. And we want to test switching to make sure that all of our sources are working. I could start setting up the control system at this point, but it's good to test just to make sure everything's working as expected before we move on to controlling or programming our control system. AMP VLAN is giving us a grid system for the transmitters and receivers that we've configured. So we set up this system for 8 receivers, 4 on switch 1, 4 on switch 2, and 8 transmitters, 4 on switch 1 and 4 on switch 2. Even though, remember, not all of the transmitters are there. So by default, the window is going to have nothing shown because it's not telling us what's currently set up. It's only tracking what we've changed. But by default, the whole system is watching source 1. So everything's watching transmitter 1. Up here on our televisions, you remember we had TVs 1 through 4. Our first 4 receivers are on the first switch. So if I change TV 2 to a different source, TV 3 and TV 4 to different sources, I've got switching. We go over to my second switch. Because the first 4 receivers are on the first switch, the next 4 are 5, 6, 7, 8. So we can switch 5, 6, 7, and you can't see 8, but you'll just have to believe me that 8 switched. Now on AMP, you'll notice that I've got sources assigned to transmitters 1 and 2 in the column, but nothing on 3 and 4, and then transmitters 5 and 6 are showing on some stuff. Remember, we're missing 2 transmitters on the first switch. Transmitters 1 and 2 on the first switch are active, but transmitters 3 and 4 on the second switch are not. There are blanks ready for expansion. And then we jump to switch 2 for transmitters 5 and 6. And I can see that on my report file. My report file is showing transmitters 1 and 2, 5 and 6 are active. So if you do have multiple switches, keep in mind that the ordering, as far as your control system goes in order of ports on the switch. So whether the ports are active with transmitters or blank, those ports are still counted. So in this system, we've got transmitters 1, 2, 5, and 6 that are active for now with room for expansion. And I can switch them to anything I want to through my AMP software. At this point, we're ready to program our control system. All right, so we've set up our multi-switch system using AMP VLAN. We're good to go. If you've got any questions, please feel free to contact us at support, and thanks for watching.